Welcome to Whizzy Facts, where we dive deep into the mysteries of Earth's core and the dynamic geological processes that shape our planet. Join us on an exciting journey to uncover astonishing facts and explore the hidden wonders beneath our feet. Hey there! Check this out! This is the Earth's crust, the outermost and thinnest layer. Below it lies the mantle, which is significantly thicker, and at the center we have the core. Wait, what's going on here? Uh-oh, it looks like the core is leaking into the mantle. We need to act fast to fix this leak. What do you mean it's been happening for thousands of years? The Earth's core is actually quite fascinating, with its unique characteristics, including a mysterious metallic orb and temperatures nearly as hot as the surface of the sun. This is just one of the many enigmas surrounding our planet. Apparently our planet's core is leaking gas. Is that a threat to us? Is it going to explode if someone lights a match? Not really. The gas in question is a rare isotope known as Helium-3. Helium-3 is a variant of helium that contains one neutron instead of the usual two. Most of the Helium-3 in the universe was formed shortly after the Big Bang, making it quite ancient. As the solar system developed, this gas became trapped deep within the Earth's core, shielded from cosmic impacts. For billions of years, this gas remained hidden within the planet. While we've known for some time that trace amounts of helium-3 occasionally escape to the surface, the exact mechanism behind this leakage was unclear until recently. A breakthrough occurred with the discovery of exceptionally high ratios of helium-3 and its more common counterpart, helium-4, in ancient lava flows on Baffin Island, located in Canada's remote Arctic archipelago. The most astonishing part is that these findings represent the highest helium-3 ratios ever recorded on land. The research indicated significant levels of helium-3, suggesting that volatile elements from the solar nebula, the cloud of gas and dust that formed our solar system, have remained in the Earth's mantle since the planet's early formation. This discovery was made in lava flows that erupted around 60 million years ago when a new seafloor was forming as Greenland and North America separated amicably. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, employed advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, preserving the helium as it rose from deep within the Earth. The scientists found about 10 million helium-3 atoms per gram of olivine, which is an astonishingly high concentration for Earth. The Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection, where the rocky interior stirs and moves like boiling water. Magma plumes that rise from the mantle to the surface carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere, but some gets trapped in crystals within the lava, allowing scientists to study its origin and movement later. Now, let's trace the journey of helium-3 in the Baffin Island rocks. This journey began at least 100 million years ago, with mantle plumes carrying the helium likely taking tens of millions of years to reach the surface. This means helium-3 has been leaking from the Earth's core for millennia. It also suggests that our planet likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an excellent location for studying the Earth's deep interior, as its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to this remote island which features towering cliffs, icebergs, and even polar bears. Local organizations assisted the team in accessing the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within the Earth. Could there be significant amounts of other light elements such as carbon and hydrogen? These elements are essential for life and could provide further insights into the planet's habitability and evolution. For example, the core's unexpectedly low density might be explained by the presence of these elements. Additionally, understanding the movement of helium-3 could help track the behavior of other gases across the core mantle boundary. But this isn't the only surprising finding about the Earth's interior. Let's head to Turkey's central Anatolian plateau, where the Earth's crust appears to be slowly dripping into the planet's interior. This phenomenon, known as lithospheric dripping, continues to shape the region's surface geology. Lithospheric dripping occurs when the lower part of the Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. That's the idea. This process has been ongoing for a long time, and as this material moves downward, it pulls the crust with it, causing the surface to sink. Consequently, we observe new depressions or basins. Once this viscous material detaches from the crust and sinks deeper into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising creates the shifting landscape in areas like the Kona Basin in the central Anatolian Plateau, where geophysicists have observed signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Kona Basin. All of this points to the presence of dense material, likely a result of lithospheric dripping. Their model suggests that the Kona Basin is currently in the later stages of this process, while the surrounding central Anatolian Plateau has been uplifting over the past 10 million years. The Kona Basin is sinking at a rate of about an inch per year. While this may seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen about half a mile over the last 10 million years, likely due to lithospheric dripping. However, the discovery of the Kona Basin reveals that this process is not a one-time event, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused subsequent events that led to the formation of the Kona Basin. To validate their model, the researchers conducted a laboratory experiment simulating the lithospheric drip process. They filled a tank with a highly viscous silicone polymer to represent the Earth's lower mantle, used a mixture of modeling clay for the upper mantle, and ceramic spheres in silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed the drip descending slowly. Within 10 hours it began to fall, and by 50 hours a secondary drip had started. The results confirmed that even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Kona Basin. This experiment demonstrated that lithospheric dripping can lead to vertical deformations even without horizontal movements, and that one event can trigger additional drips that alter the Earth's surface. This discovery enhances our understanding of how the Earth's crust behaves over long periods and how tectonic processes can shape the landscape. As a bonus fact, back in 1692, Edmund Halley, yes, the same Halley known for Halley's Comet, proposed that the Earth might be hollow. He envisioned layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even speculated that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel Journey to the Center of the Earth. And there you have it. From the mysterious leaks of helium-3 from Earth's core to the fascinating processes shaping our planet's surface, we've uncovered some truly mind-blowing facts today. If you enjoyed this journey into the depths of our Earth, don't forget to give us a thumbs up and share it with your friends. For more incredible discoveries and insights, be sure to subscribe to Whizzy Facts and click on the videos popping up on your screen. Keep exploring and stay curious. Until next time.